Hey everyone, in this video we're going to be looking at solving radical equations and inequalities. So I'm just really going to work out a few problems with you today and just look at how to solve a whole bunch of different radical equations. Here's some simple steps that you can use to solve radical equations. I'll leave those here on the screen. So let's just look at an example. Let's take this first equation here and let's solve that. So the first step you want to do kind of with these is isolate the radical. So let's get rid of that 2 first. So we can see that if we divide by 2, we'll be left with just x plus 1 over here. X plus 1. And I'm going to be writing with my mouse again today, so forgive the bad handwriting. All right. So if we divide by 2, 4 divided by 2 is also 2. So we'll have this as our second step. Now to get rid of the radical, we have to do the opposite of square root. The opposite of square root is to square something. So just remember that opposite of square root is to square. Opposite of cube root is to cube. Opposite of the fourth root is the fourth power, etc. So if we do this, if we square this side, then we'll just have x plus 1. All it does is get rid of that radical. And then if we square the right side, 2 squared is 4. Okay? And then we can subtract 1, and we'll have x equals 4 minus 1 is 3. Now, with these problems involving radicals, you want to check your solutions because sometimes you can get what are called extraneous roots, which are not actual answers. They're not solutions to the equation. So if we check this real quick, if we stick 3 in here, 3 plus 1 is 4, square root of 4 is 2, 2 times 2 is 4, so that works. All right, so this is a good answer right here. I will leave part B for you to work on. See if you can solve that one out and get an answer. Here's also a real-life problem. If you'd like to work that one out, you can do that as well. We're going to move on and look at something a little bit different. So I was talking about those extraneous roots or extraneous solutions. So we're going to look at an example that includes one of those. So looks like we already have this isolated on one side of the equation. So we can do the opposite, which is to square this. So we'll be left with 7x plus 15 on the right side. That's a bad 5, but we'll just leave it. And then we want to square this left side. So x plus 1 squared, we're going to have to kind of FOIL it. So x plus 1 squared comes out to be x squared. X times 1 times x times 1 is 2x. And then 1 times 1 is 1. All right, so we're left with, so x plus 1 squared is x squared plus 2x plus 1. And then we can subtract the 7x over here, so we'll have x squared minus 5x. We could also subtract this 15 over to here, and we'll be left with negative 14. 1 minus 15 is 14, and then we'll just have 0 on the right side. I guess to solve this, we may try factoring it. It's a quadratic equation at this point, so we can try factoring it. I think factoring will work with this equation. So we'll have an x and an x. This is a minus sign, so we'll have a plus and a minus, opposite signs. What times what equals 14? I think 7 times 2 will work for us. 7 times 2. And we can see that negative 7 plus 2 is negative 5. So that works. And then we can say x plus 2 equals 0. So we can see one of our solutions is going to be negative 2. And x minus 7 equals 0, so one of our solutions will be 7, because 7 minus 7 is 0. Now, go back and check both of these solutions into the original equation, because one of them doesn't work. We could try, let's try 7, I guess, first. So 7, if we stick 7 up here into x, 7 times 7 is 49. 49 plus 15 is that 64. So we'll have square root of 64. So let's just expand this over here. So we'll have x plus 1 equals square root of 64. Don't worry about that bell, guys. All right, x plus 1 equals square root of 64, because 7 times 7 is 49. 49 plus 15 is 64. And then we can add 1, because I don't think you can take square root of 64, right? Or can you? Oh, wait. I'm being a silly goose here. This x right here is 7. We're supposed to replace the 7 here and here. So 7 plus 1 is 8. Square root of 64 is 8 as well. I don't know what I was thinking, guys. Anyway, that works. Okay? 8 times 8 is 64. I don't know what I was thinking. So, this is a good answer right here. This is a good answer. Let's try the other one. So let's take -2, substitute it in for x on both sides, and see what we get. So we'll have a -2 plus 1, which is -1. And then square root of 7 times 1, or 7 times -2 is -14. -14 plus 15 is 1. Square root of 1. What times what equals 1? 1. So we can see -1 does not equal 1. This is an extraneous solution. All right. So I think that's kind of the idea that they're going for here, that this solution doesn't work. Let me make sure that I told you right. Because, yeah, all right. So -1 does not equal 1. Extraneous solution. So this is the right answer. X equals 7, but x equals -2 does not work. That's not an answer. All right, it's not an answer. Here's our only answer right here. All right, moving on. Let's look at how to solve an equation when there's a radical on both sides of the equation. So for example, we have a square root on both sides. Here's what we're going to do. Remember, to get rid of square roots, we take the square. So we're going to go ahead and square both sides. We're going to go ahead and square both sides. This right side is going to be kind of sloppy because we're squaring x plus 2 plus 1. So let's think of this as x plus 2 times x plus 2. That's just going to give us x plus 2. X plus 2, I'm doing FOIL here. X plus 2 plus, x plus 2, square root of x plus 2 times 1 is just square root of x plus 2. So we'll have 2 of those, right, with FOIL, because then it's 1 times square root of x plus 2. So we'll have 2 square root, oh my goodness, this is very sloppy. Let's try this again. 2 square root of x plus 2. And then finally 1 times 1 is 1, so we'll have a plus 1 out here. All right. And then this right side, we'll also square this. And when we square this, we're just left with 3 minus x. That was easy. Okay, let's clean this up a little bit. So we still have a radical. Let's isolate this radical because there's only one radical now. So let's isolate it. We can combine this 2 and this 1 to get 3, and then we can subtract it over to here, and 3 minus 3 is 0. And then we can also subtract this x. So we'll have 2 square root of x plus 2 equals, like I said, 2 plus 1 is 3. 3 minus 3 is 0, so 3's kind of cancel. We also have this negative x, and then we're subtracting an x, so we'll have negative 2x. Divide by 2. So we'll have x plus 2, square root of x plus 2 equals negative x. Square both sides, and we'll be left with x plus 2 equals x squared. And we can see that at this point we have a quadratic equation, so we could subtract this x and this 2 over here. So we'll have 0 equals x squared minus x. We subtracted the x over, and minus 2. All right, we could probably factor this. So let's try that. We'll have an x and an x, plus and a minus, and then we'll have a 2 and a 1. Negative 2 plus 1 is negative 1, so that works. So one of our solutions, again, ignore the bell, guys. Sorry about that. All right, so one of our solutions will be negative 1, because negative 1 plus 1 is 0. And our other solution will be 2, because 2 minus 2 is 0. And we can check both of these answers if we plug them into the original equation, because I think one of these is going to be extraneous. And just to save a little bit of time, let me show you which one it is. The extraneous solution, I think it's going to be the 2. So let's look at that. So let's plug this 2 in up here. So we'll have square root of 2 plus 2 plus 1 equals square root of 3 minus 2. Okay, 2 plus 2 is 4. Square root of 4 is 2. Well, 2 plus 1 equals 3 times 2 is, it's 3 minus 2. 3 minus 2 is 1. Square root of 1 is 1. 2 plus 1 is 3. 3 does not equal 1. So this x plus 2 right here, this is an extraneous solution. It does not work. But if we test the negative 1, then it does work. And I won't go through that right now, but just trust me. If you plug in negative 1, and it does work. So this is our solution. X equals negative 1. X equals 2 is an extraneous solution. All right. How do we solve an equation when we have a rational exponent? Really simple, really easy method here, guys. What you're going to do, first of all, is isolate the rational exponent, the term with the rational exponent. So let's subtract the 2 over. So we'll have 2x to the 3/4 equals, subtract that 2, we'll have an 8 here. Now, to get rid of this 3/4 rational exponent, what we're going to do is raise everything to the opposite, so the inverse of that fraction. So instead of 3/4, we're going to raise everything to the 4/3 power. So we're inverting the fraction. When you do that, it will get rid of the rational exponent over here. So we'll just have 2x. And then we're raising this number over here, whatever's on the right side, by the 4/3 power. Again, you just raise both sides to the inverse of that rational exponent to get rid of it. So if we use the calculator, 8 to the 4/3 power is 16. So we'll have 2x equals, and actually you don't need a calculator for that. You could probably figure that out with that one. But that's 16. And then divide by 2, so we'll have x equals 8. Right, so that's how you solve an equation with a rational exponent. Just isolate that term, and then to get rid of the rational exponent, you just raise everything to the inverse of that fraction. So you flip the fraction over. All right, and you'll be good. This is the exact same thing, so I'll let you solve this one if you'd like. You're going to raise this is already isolated, so go ahead and raise this to the inverse of 1/2, which would be 2, and solve it. And I guess I'll go ahead and give you the answer to that in case you do want to work on that. You're going to get 2 answers. You're going to get x equals 6 and x equals -5. All right, so see if you can solve that out and get those answers. I'll tell you that one of them is extraneous. So let's see if you can figure out which one of those is extraneous. You'll plug them into the original and see which one doesn't work. So there you go. Let me know in the comments which one it is. All right, last thing, solving radical inequalities. Exact same thing as solving radical equations. So let's solve this. We want to isolate the radical first, so let's divide by 3. Remember, all your inequality rules apply, so if we're dividing by a negative, we would need to switch that sign. We're going to leave it the same for now, or that operator, I'm sorry, the operator. Divide by 3, 12 divided by 3 is 4. To get rid of this radical, do the opposite. So instead of square root, we're going to square. 4 squared is 16. Add 1. And there you go. Now, there's one other thing we have to look at. So x has to be less than or equal to 17. This is what we're seeing here. But we also have to analyze this radical because we know that we can't have negative numbers underneath the radical. So what values of x would give us negative numbers? Well, we know that if x was 1, 1 minus 1 is 0. That's okay. But if x is any number less than that, any number less than 1, you know, like what if it's 0? 0 minus 1 is -1. Now we have a square root of a negative. So anything less than x equals 1 is going to give you something smaller than 0 underneath this radical. So we have to say not only does x have to be less than or equal to 17, but x also has to be greater than or equal to 1. Because if x is less than 1, then you get a negative number underneath this radical, and we can't have negatives under the radical because we want rational answers. So not only does x have to be less than or equal to 17, but x also has to be greater than or equal to 1. So test that, guys. One easy way to test that, to figure that out, is set this equal to 0. X minus 1 equals 0. Or you could say it like this. X minus 1 has to be greater than or equal to 0. Has to be greater. Whatever's inside that radical has to be greater than or equal to 0. So if we add the 1, we can see x has to be greater than or equal to 1. So that's how we got that. All right, has to be greater than or equal to 1. So we can say x has to be the numbers between 1 and 17. It can't be, it has to be less than 17, but it has to be greater than 1. Less than or equal to 17, greater than or equal to 1. So here you go in one statement here. X has to be in between those two numbers. So that's solving radical inequalities. One last thing I want to show you before we end out the whole video, and that is we can use Desmos to solve some of these problems. With all equations, we can use Desmos to check our solutions. So let's just see if we type in this equation here, what we would see, or I'm sorry, this inequality. So we'll have 3 square root of x minus 1 less than or equal to 12. And we can see here the exact same thing that, and it's not giving me the little dots to click on. But we can see, we can check it though. We can remember that it had to be greater than or equal to 1. We can see that's right at 1. And it has to be less than or equal to 17. And we can see that it that is going to be less than 17. So here's all of our numbers. We can see that's verified by Desmos. We could check one other one. So this one, that one is going to let you do on your own. So this one right here, we could type in 2x. Maybe we should put that in parentheses. And then to the 3/4 power plus 2 equals 10. Now, I don't think this is going to actually give us a dot where we can see. What we can see is right at 8, and that was our solution. To get it to show the dot, one thing we can do is subtract the 10 over here. So get everything onto one side. So if we subtract 10, that would be what? 2 minus 10 is -8. And then you just don't write the right side of the equation. And it'll then give you a dot and show you right where it crosses at 8. Either way, we get 8. So you can see that. So remember, you can use Desmos when you're trying to solve equations. All right, guys, I guess that's going to be it for me. If you have any questions, let me know. But thanks, guys, for watching, and I'll see you in the next video.